So this is our third lecture we're going to do on gap calcs. And so if you've done the first two lectures and you understood especially the second one, a little more complicated situation, and now you come into the sim and they they tell you they're impressed you can do gap calcs in your head, but now they've really got a stumper for you because in this situation we've got our two beams here and we have them set up and the doctor wants a gap on the surface. However, they didn't set up as SSD beams but rather as isocentrically. So it's 100 SAD at some depth in the patient, and they think this is going to be very confusing to try to figure out. They still want to match at 6 centimeters, but let's just say let's say the SSDs are let's see, this one is 90 centimeters. To make matters even worse, this is 90 and this one's let's call it 89 9.5, so they're not even exactly the same, and it's just looks like a very confusing case, and they don't know how they're ever going to figure out this gap right here. So how are you going to do it? Well, the first thing you're going to do actually is ask them what are the jaw settings for each of these beams. And specifically, you want to know on this upper beam, you want to know just the collimator setting, not what it is up here, but just say what is the collimator setting. And they tell you that the collimator here on this jaw, on the lower part of the jaw is let's say that's 10 centimeters. And then you ask, well, what's the collimator setting on this beam? And they tell you, well, that is 15 cm. So this beam, the collimator setting on the upper part is 15 centimeters, and this part is 10 centimeters. And and you're going to calculate the gaps using that information. You're going to try and calculate this little G1 and G2 using the information you've been given, but this just looks like a confusing mess and looks like quite a difficult geometry problem. But is it? Let's take a closer look at it. Alright, so we're going to look at this again just as a geometry problem, not as a radiation problem, but just as a simple geometry problem. And so here we've got our beam coming in, and I'm just looking at half the beam, just the half that we're interested in. In other words, this is the central axis coming down here. Of course, there's more of the beam coming over on this side. We're not worried about that. We're just looking, here's the central axis, here's the edge of the beam coming down, and this is our depth that we're going to match at. So this is our depth D, here's G1, this little gap, and this is from here down to here is 100 centimeters, that's our isocenter. And because our jaw setting on this part of the beam is 10 centimeters, so the lower jaw setting is 10 cm, that is defined at isocenter. So that's defined down here. This is 10. And we said it was 90 centimeters SSD, but you don't even have to know that because this triangle here is still similar to this one here. And I'll try to prove that to you. So first of all, again, let's look that we've got, here's a right angle, here's a right angle. So this and this are each 90 degrees. And this angle here is the same as this angle here. We've said that in the previous one, in a previous lecture. But do you also see that because this is horizontal, this is horizontal, this line is coming down, and hopefully you remember this from high school geometry, this angle here is the same as that one there. Do you see that? These two are the same. And like we said previously, this angle here then is the same as that angle here from this triangle is the same as that triangle, but also this bigger one here is similar to this triangle. And since this is really just a geometry problem, not a radiation problem, we can get our ratios here from what we know. We don't worry about what the SSD is, just do we know two sides of a similar triangle, and we do in this case. Here's the equation. So again, here's our triangle. G1 is to D, is to this depth, as 10 centimeters is to 100. So now we could back project this and try to, if we figure out that this is, I think I said it was 90 centimeters SSD, and so I could say that if this is 90 here, 90 over on this side, and I could do the math to figure out that this side would be 9, but again 9 is to 90 as 10 is to 100. It's going to be the same ratio because these are also similar triangles. So my point is, it doesn't really matter as long as you know what the SAD is in this case, and if you know the jaw setting, you still have a ratio of triangles that you can use. All right, now let's put in our other beam, and again I'm just going to put in the half that we're interested in over here, and this one we said again was at 100 centimeters SAD. This jaw setting down here was 15 centimeters, and we're going to want to calculate this little gap here, G2. So we have a similar situation here. G2, this little triangle here, is the same as this triangle, or similar to this triangle here. Again, we've got, here's a right angle, there's a right angle. This angle here is the same as that angle there, and this angle is the same as this one down here. Just again, we got a straight line, two horizontal, so this angle is the same as this angle. I guess this might be taking you back to maybe high school geometry is bad memories for you, but it should be pretty straightforward. And then this angle here is the same as that angle there. So again, we have this triangle here is similar to this big one here. So we really don't care what this triangle is. We could figure out, okay, if this is 89.5 SSD and try to figure out what this is on the surface. But it doesn't matter because we'd just be using geometry to figure that out. We already have the similar triangle right here. So this triangle is similar to that one there. And again, if we write out our equation again, G2 is to this depth as 15 is to 100. There. So it's again, we can just, if we just know the jaw setting, even though these are overlapping in looks like a very complicated way, our geometry is still the same as our SSD problem. Because if we know that the jaw setting is defined at 100, we're just going to be the jaw setting over 100 centimeters. Here's the jaw setting over 100 centimeters. So our geometry is going to be the same. All right, so here's our, just put another piece of paper, or not paper, but electronic paper. So we have G1 is to D as 10 is to 100, and G2 is to D as 15 is to 100. Let's go ahead and write this out. And their numbers, our depth was 6 centimeters. So G1 is 10 divided by 100 times 6. So that is going to be 0.6. You can prove it to yourself with the calculator if you like. This is going to be 0.9. So like in our previous lecture, 0.9 times or plus 0.6 is equal to 1.5 cm gap when we add those two together. So even in this very complicated looking situation, it again is just a very simple geometry problem. we would just take our jaw setting, which is 10 divided by 100, and 15 divided by 100, multiply it by our depth, and that gives us our two gaps. So again, these, like I said, these look more complicated than they are, but if you just know some basic geometry, they're actually very straightforward problems.